Hey, I'm Lucas Yelnyevich, and I'm going to walk you through my Project 30. So as you can see, I am reaching 72 frames per second consistently, and I also have 1 unit equals 1 meter scale that matches the Unity scale. So those are the two requirements that I've always been following throughout these projects. And the same thing in Project 1 and 2, I'm still in the same environment. It's a snowy, cozy environment where the user can just relax, play with snowballs, which I'll show later. And they can also have some intrigue because of this cave in the back. Like, oh, I wonder what that's for. It looks really ominous. But today, I'm not going to focus on that. I'm going to focus on the interaction techniques I have. But first, I want to talk about uh, locomotion techniques because they are in my design document. I still have the same things, Um, I still have smooth locomotion, moving around. I still have the reorientation technique to turn, so it's easier for users to navigate this environment. And also have the ability where users can't stick their head into objects. If I try to stick my head, I move backwards. The camera shifts position. But those are all the other requirements that I don't really need to focus on, because today I'm going to focus on the snowball and how that plays into my interaction technique. Okay, so as you can see, I point this forward, and if I click this trigger, this one right there, I get a snowball. However, as you can see, it's not sticking in my hand. Instead, the players need to use this trigger on this side, left side of the controller, to grip the snowball in their hand. The reason why I went with the point interaction technique, or just a point technique with this ray, is because it's much more convenient than having to get down on the ground and try scooping it up. So even though it's low fidelity, it's more convenient and it reduces motion sickness or cyber sickness because you're not moving around all the time. Okay, so as you can see, when you have the snowball in your hand, you can move it. You can use manipulation techniques. So there's moving it around. And there's also rotating it. So those are two techniques I implemented. And you can also throw it, right? So, as you've been hearing, the snowball also makes a sound when it hits the ground. And it can also make the sound when it collides with other objects in the scene. The snowball follows different collisions as it collides with either the tree or anything like the ground or anything in this scene. It will make a sound. That is showing that as the snowball collides with something, it will make a sound and it will disappear. It also follows physics because, just the normal gravity of it is the way it's interacting. You can tell that this is a normal. Oh damn, it's not. You can tell that this is a normal snowball and it follows physics really well in terms of its collisions and its gravity. And this is a and this meets the requirement where the snowball needs to follow physics by adhering to collisions, as you can hear the sound and it's disappearing, and the gravity, as you can tell with this throw, right? And the last thing about the snowball is I got this sound from DJ Art Musics. The sound where, it collides with the ground. I don't know if you can hear that part, but the sound you've been hearing is from DJ Art Music. Today I showed you how my project has still been following guidelines such as the FPS and the Unity measurements and overall cohesion of the environment. And I also showed you how my snowball adheres to physics with gravity and its collisions. And I've also showed you the technique I'm using to even get the snowball in the first place and the different manipulations with rotating and movement. Thank you for listening to my Project 3.